All right, we're in part 2 now, and we're picking up to 74. Now, this is phrased kind of poorly. It's like a Colloge question. When you look at this thing, what do you think is the most important part of the central limit theorem up here? Well, to me, it's the sample size over 30 means it's normal. We like this idea because the sample size of 30 is simple to deal with, and the normal distribution is easy to deal with. I don't want to deal with a right-skewed distribution, a left-skewed distribution. I don't want to deal with any of that. That's kind of crazy, all right? So I'm going to pick that. And I know a lot of people agree with me. So we're looking for a sample size over 30 to be normal, okay? And that's going to be the most important part. Why is the central limit theorem important? All right? It allows us to use a normal distribution for any kind of data. Well, that's coming in because the central limit theorem is only for a sampling distribution, not any data. So that doesn't work. Because of the any kind of data, it doesn't work. The other thing it doesn't talk about the sample size being large enough. So I don't like that. B, it tells us that any data can be approximately normal if we take a large enough sample. Well, now this has got the large enough sample on it. This is good. Okay? Just like up here, any kind of data, any data is wrong. This is only for a sampling distribution. Okay? Now, this tells us any sample mean can be approximately normal. Sample mean is good, the approximately normal is good, but it doesn't say large enough sample. It doesn't say n greater than or equal to 30. So right now we're striking out. Almost everything is wrong. Part D says it tells us any sample mean would be unbiased. That's good because that's mentioning sampling distribution. Part 1 says unbiased. That's even better. But our problem is it doesn't answer the question. It says, why is it most important to the study of statistics? Okay? And being unbiased isn't the most important part, so that's still not right. So my answer is E. Again, the most important part would be if sample size is large enough, we can follow a normal. All right? So let me set that aside. We got 2 problems left. The term sampling distribution refers to what? All right? Well, it refers to the distribution of our sample data. No. We've talked about this. A sampling distribution is a list of sample means from many samples of the same size. This is not that. It is not a list of sample means from many samples of the same size. Sample data is not that, so we get rid of that. The standard normal curve. No. Okay, that has nothing to do with this definition right here. The distribution of parameters. No. Okay? There is no distribution of parameters. There's one population mean, so that's no. Okay? The distribution from which we took our sample. That's a little better, but it's still no, because we're looking for a list of sample means. This says the distribution of our sample statistic. That's better, because sample statistic is the same thing as saying sample mean. The distribution is the same thing as a list. So this is a list of sample means, which matches this definition here. So my answer is E. Okay? Now this last one down here, this is using math. There's 2 types of math with central limit theorem. One is categorical, which we did on this one. Problem 73, where we found the mean and standard deviation with program PROP. Then we used it to go a little bit further and found the probability that our sample proportion was 0.51 or more. Okay? On this one, this is going to be the numerical version. And I know it because I glance at it and it says mean of 2, standard deviation of 0.08. So I know we're dealing with numerical. Suppose the volume of a Pepsi in a 2-liter bottle is normally distributed with a mean of 2 and a standard deviation of 0.08. If I purchase 4 bottles of 2-liter Pepsi and find the average volume is 2.1, what's the probability the average volume of the 4 bottles of 2-liter Pepsi will exceed 2.1? All right, now, some of the key things in here is this already says normal, okay? So I don't need the sample size to be over 30. It's okay if the sample size is less than 30. The other thing is I have 4 bottles. That tells me n equals 4. So I still have a sample size, so I still have to go down this central column here. Numerical because it has a mean and standard deviation. I have a sample size of 4. I don't care about this because it does say normal. So I don't need to worry about it being large enough. Okay? So it says normal, I can draw a bell curve. Now, we're going to use the population mean here. The population mean is going to be 2. We're going to take our standard deviation of 0.08. We're going to divide by the square root of 4. I'm going to deal with that when I run my calculator program. I don't need to find the number now. The program's fine with that. And I want to find the probability the average volume of 4 2-liter bottles of Pepsi will exceed 2.1. Okay? So when I go to work this is just program normal, nothing more. So I'm going to turn on my calculator. I'm going to hit clear. I'm going to push program. I'm going down to program normal. Okay, making sure we can see it on the video. We can. This was a little off the video. However, I'm sorry about that. Right there, you can see the whole thing now. I need to put some tape on here so I know where my screen is. So there's my normal program. Press enter to start it. Enter the mean. The mean is 2. So I'm going to write that over here. The mean equals 2. We're doing program normal. Okay. Our standard deviation is 0.08 divided by square root 4. I'm typing that in. Okay. It's fine that I type it in like that. Press enter. I'm going to pick right end. Okay, picking right end. So I pick right end. Shading starts at 2.1. Okay, just checking to make sure everything's on the calculator screen. I'm going to move the problem up a little bit. And when I press enter, it tells me the probability is 0.0062. And I look on here, and that's answer choice B. So there you go. There's a run through of all the problems we missed. It took me a little bit of time, but about 20 minutes, 25 minutes. But you have them all. You're going to have the videos. I'm not going to get them up as quick as I said because it's going to take some time for the videos to render. And good old Suddenlink doesn't like me uploading anything, so they tend to punish me for uploading stuff. But anyhow, I'm going to get off the camera. I'm going to go start uploading this so you all may enjoy it as soon as possible. It should be uploaded by tomorrow afternoon at the latest.